Chapter 11, number 35. A handheld shopping basket, 62 centimeters long, has a 1.81 kilogram carton of milk at one end and a 0.722 kilogram box of cereal at the other end. Where should a 1.8 kilogram container of orange juice be placed such that the basket balances at its center? So to put all of this sort of into a picture, we have the bottom of the basket. I'm not going to draw the sides, but bottom of the basket. And they want to pivot the basket at the center. So we'll do that. And if that's the case, well, then we know that this is 31 centimeters and this is 31 centimeters. And we have over here the milk, which I'm going to call object 1. And we have over here the cereal, which is object 2. And we want to know where do we put object 3 so as to balance at the center. And since there is less weight on the cereal end box, it would have to be somewhere on the cereal end. So something like that. And I'm going to call that distance just x, because it's what we're looking for. And then we'll invoke the balance principle, and the balance principle tells us that the torque that's clockwise has to equal the torque that's counterclockwise or anti-clockwise. The torque that's clockwise is coming entirely from box 1. And so this is going to be the let's actually put this out here. The torque clockwise is 1.81 kilograms times the 31 centimeters, and then times g. I'm not going to write g out because I know it's going to cancel later. Also, I'm not going to convert to meters because in the end I want my distance to be in centimeters anyway, and the units will work out even though they're not the standard units. All right, our torque in the anti-clockwise direction would come from two things. It comes from the cereal box, 0.722 kilograms times 31 centimeters times g. And then additionally, there is the new thing, the 1.8 kilogram box at a distance x. Now we just equate them. So we say 1.81 times 31 kilogram centimeter g, whatever that is, has to equal 0.722 times 31 kilogram centimeter times g plus 1.8 kilogram x times g. And I left that out here, but this was times g up here as well. The first thing is to notice that that means that our g's are in fact all going to cancel, that this g and that g and that g go away. They're not that important. And so I can say that 1.80 kilograms times x has to equal 1.81 times 31 kilogram centimeters minus 0.722 times 31 kilogram centimeters, which turns out to be 33.728 kilogram centimeters. And then we can say then that if 1.80 kilograms times x is 33.728 kilograms times centimeters, divide both sides by 1.8, and we get 18.7 centimeters from the pivot point. The book, for whatever reason, decides to say, well, they end up finding this entire distance, all right, which is not clear to me why you do it, but they measure from the meter, so we can see that our distance, L, is x plus the 31 centimeters towards the pivot, and that's 49.7 centimeters, which is what the book says at the back, so we agree.